Hey y'all, this is Sarah Morrison. This is section 3.1, inverse functions. You probably already learned it in college algebra, but we're just going to kind of review some college algebra stuff at the beginning, just in case we didn't get it all. All right, first we're going to start off with something called a function, and you probably already remember this definition from college algebra. To be a function, the x cannot repeat in the t-chart or on the picture. So if we're looking at a picture, let's say I have a side-to-side parabola. This is bad because, or not a function, because there's 2 points that have the same x value. So this is a boo-boo picture. So to be a function, the x cannot repeat. To be something called a one-to-one function, this is where the y's actually count also. So the x and the y cannot repeat. Yeah. Okay, so for functions, there can only be one of each x value. Or if we're looking at these ordered pairs, let's look at the x's. I got 2, 4, 7, -2. Okay, those are all different and they don't repeat. So all these x's are different. They don't repeat. That's great. So because the x's are different and they don't repeat, that means it's called a function. Now let's see if any of the y's repeat. Well, look at your y's. 1, 2, 3, 1. Uh-oh. Look at that 1 that repeats in the y. So the y's repeat. So it's not one-to-one. Yeah. Okay, so it's just called a function. It's not called a one-to-one function. Okay, if this last ordered pair, if we would have had like -2, 5, then yes, it would have been one-to-one. Because one-to-one means that in the domain, let's say you have two numbers, A and B, in the domain. When you plug those numbers, A and B, into your equation, like the function, the f thing, whatever pops out should be different. So one-to-one means all the x's are different, all the y's are different. There's no repeating x's or y's. Okay, let's look at this second picture. Over here on the left, this left circle is the x's and this right circle is the y's. It's called a mapping. And so if we follow what the arrows are, this says that Batman goes with Joker. Okay, well, there's just one villain with one hero, so that looks good. Then we have the Green Lantern with Sinestro. Okay, so for only one input, we have one output. Or for one hero of Batman, we only have one villain of Joker. So the X's do not repeat. Batman is not the hero for the Joker and the Sinestro. Batman is only the hero for the Joker. So the X's are not repeating. Okay, then we have Wolverine, and I think that's supposed to say Sabretooth. Okay, so this is a function, and it's a one-to-one function. And the reason is because all the x's, or all the inputs, have only one output that matches with it. If there was a repetition, it would not be 1 to 1. So on this first example, with the repetition of the y's, it's not 1 to 1. Okay, if this would have said maybe, Batman goes to the Joker and the Sabretooth, that would have been no. Yeah, okay. So only one input can match with one output, or one x value for one y value, to be a 1-to-1 function. All right, let's see. It says a function is 1 to 1 if no horizontal line intersects the graph in more than one place. Okay, this is actually what we just did, only we didn't look at the picture. Okay, if you think about if you think about this first example up here, it was not 1 to 1 because those y's repeated. Okay? Well, back in college algebra, there was something called a vertical line test. Vertical line test to see if something was a function. And the vertical line test tested to see if your x is repeated. Okay, that's the vertical line test. The horizontal line test, we draw a side-to-side line. And if it hits more than once, that means the y's repeat. And it's not a 1-to-1 function. So, to be a function, the vertical line test has to only pass through your curve once. To be a 1-to-1 function, not only does the vertical line test only pass once, but so does the horizontal line test. They both have to only pass once for it to be a 1-to-1 function. Okay, so let's look at this number 3. We're trying to see if it's a 1-to-1 function. Well, first let's draw a horizontal. Horizontal. Yes, it's 1-to-1. Because every one of these x values has a different y value. Like this x value has a y value of -2. This sucker is 1, so like -1. This sucker has a y value of 1. This sucker has a y value of 2. This sucker has a y value of 3. This, you get what I'm saying? So there's all different y values. Okay, let's look at number 4. We're going to draw a horizontal line, and not there. Look at all these same y values. So this means the y's repeat. And remember, to be a 1-to-1 function, there can only be one x value with one y value. Nothing can repeat. So this would be number 4 would be an example like this number 1, where 2, 1, and, or where was it? Yeah, here it is. 2, 1 and -2, 1. That would be like -2, 1 and 2, 1. That's where the y's would repeat. So number 1 and number 4 are the same. It's an example of something that is not 1-to-1. Yeah. Okay, let's look at number 5. Draw a side-to-side line. Oh, I just hit once. Oh, okay, so that's good. So 1-to-1 means either the x's and the y's do not repeat in the ordered pair, or in the mapping, you only have one arrow going from one word to another. There's no double arrows. If we're looking at pictures, you can draw a side-to-side line and only cross through your curve or your dots just once. Okay, let's look at number 6 and 7. It's the same thing, only now we're talking about equations. Okay, so we want to tell whether it's 1-to-1. All right, well, 1-to-1 means there's a different y value for every x value, or we could try and draw the picture. Okay, if I try and draw the picture, 3x plus 2 looks like, if you don't remember how, put it in your calculator, in y equals. And it looks like that. Okay. Okay. This 3x squared, if I were to graph that in my calculator, okay, it looks like that. If I were to come up with a t-chart, like from my table, for this one that I was just on, this number 7, the t-chart is a little repetitive. It looks like negative 1, 6, 0, 0, 1, 6. And then, oh, this is not right. It's supposed to be negative 1, 3, and 1, 3. I typed in something wrong. Okay. And then over here, for this t-chart, if we were to look at our calculator, and just look at our points. Okay, so I got all this information from a calculator. If you don't remember how to use all the calculator to get this information, it's okay. We could have gotten these t-charts by just plugging in numbers. Let's plug in negative 1 into this x value and see what pops out. So we have 3, and then instead of that x, let's put a negative 1, and then plus sign 2. And let's see, negative 3 plus, 3 times negative 1 is negative 3, plus 2 is negative 1, and that's where we get this y value. Now let's try plugging in a 0. 3 parentheses 0 plus 2, well, that pops out a 2. Now try plugging in a 1. And these are usually the numbers we plug in when we need a t-chart. So it's best just to start with plugging in negative 1, 0, 1. And we'll even do this way at the end of the semester. And you're going to wish we had something easy like this. Okay, so you can just plug in negative 1, 0, 1 into these x values to get out the y's. And now you can see that for every x value, for negative 1, there's only one y value. For negative 1, there's only one y value. For 0, it's only matched with a 2. For 1, it's only matched for a 5. So this is, yes, it is a 1-to-1. If I would have had maybe 1 and 4, then it would have said no. So if I would have gotten 2 different y values for the same x value, it would not be a 1-to-1 function. For example, over here on this number 7, when I plug in a negative 1, we get f parentheses negative 1 equals 3 parentheses negative 1 squared. Okay, you do PE first, which means do the squared. Negative 1 times negative 1 is regular 1. Times a regular 3 is, it pops out a regular 3. Yeah. Okay, but then dag darn it, when you look at this sucker, f parentheses 1, and plug in a regular 1, 1 squared is still 1, like a regular 1, times 3 is still a regular 3. Well, oh no. We have 2 of the same y values. So since the y's repeat, kind of like this number 1, where the y's repeated, we had a 1 and a 1. Yeah. Okay. Or if you're looking at the horizontal line test, like what we did on number 4, if I draw a horizontal line through this picture, I hit once and twice. So since my y's repeat, this is no, it's not a 1-to-1. But number 6 was yes, it is a 1-to-1. Okay, now let's talk about how we know whether something is an inverse. Okay, to be an inverse, first we have to be 1-to-1, as in the x and the y do not repeat. So the pictures that we're going to deal with are not these pictures where the horizontal line crosses more than once. So we're not going to be dealing with this kind of picture or this kind of picture. We're going to be dealing with a picture where the horizontal line, or that horizontal line test, just crosses through once and just once. Okay, so the x's and y's do not repeat, or the horizontal line test passes once. Okay, if this happens, then G and F, those are like the two equations, are inverses. And then it says F little circle G of G equals X for all X in the domain of G. And then the same thing, but the letters are backwards. Okay, first of all, this little circle means composition. This means F compose G. Or we are going to, that's an arrow. Or another way to say that is we're going to put G in our F. Then for this next sucker, it says G little circle F, so we're going to do it backwards. We're going to put F in our G. And you did this back in college algebra. It was just weird symbols. Okay, so this is saying if you put each equation inside of each other and all you get is equals X after they cancel, then those two suckers are called inverses. Okay, and the way we say f of x is we just call it the function. But then when we say this f to the negative 1x, that's what we call the inverse. So function is the normal f, inverse is the funky f with the negative 1 inside. And this is just saying if you do that composition and you plug one inside each other, or one inside the other, everything should cancel to x. So the whole point of the next couple of problems should be to cancel to x. Put the word x in the wrong spot. Okay, so should cancel to x. Okay, well, let's look at number 8. It says determine whether the two functions are inverses. What? Okay, so we're just going to put one of them inside the other and then go backwards. And all the stuff should cancel to x. So let's see what happens. Let's put our g into the f. Okay, well, first, let's put our f. Okay, our f is 3x plus 6. Now, we're going to put the g in it. Okay, so instead of 3x plus 6, we're going to have still the 3 in the parentheses and the 6 and the plus sign, yeah. But instead of that first equation, we're going to put that 1/3 x minus 2. Yeah. Okay. And then now let's distribute everything and combine like terms and see if we cancel to just the letter x. Okay, let's distributize. Okay, well, 3 times 1/3 cancels out. It's like super awesome. 3 times 1/3 cancels out. It's super awesome. Okay, so 3 times 1/3 is just regular x, 1x. Then 3 times negative 2 is negative 6. And then we have a plus 6. So that 3 on the outside of the parentheses cancels out with that first fraction, but not the second one, because you have to distribute it. Okay, then, let's see, combine like terms. -6 plus 6 is just 0. So we just get x, and that's awesome. That's what we wanted. Now let's go backwards. So we just did step 1. We put g into our f, and it worked out beautiful because it canceled to an x. Now let's go backwards. Let's put that f into the g. Okay, well, first let's write down our g thing. Okay, our g thing is 1/3 x minus 2. Okay, now let's put that f up in it. Let's put the f in it. Okay, let's see. So we're going to have this 1/3 and the -2, but instead of that big fat x, we're going to put big fat parentheses and the other equation. So right now we're touching 1/3 x minus 2, but we're going to plug in this guy, 3x plus 6. Yeah. And we're practicing a little fraction rule right here. We don't know it, but we are. When I take 3 times 1/3, there's a pretend 1 underneath this big fat 3 on the outside. And when you multiply fractions, you multiply left to right. You probably forgot that. So this makes 3 times 1, 3 on top. On the bottom, 1 times 3, 3 on the bottom. And that poops out a 1. Okay, so anytime you multiply a whole number with a reciprocal, it cancels out to a 1. That's where this 1x came from. Same thing down here. We have 1/3 times 3. And yeah, the 1/3 is on a different spot on the fraction, but it's the same principle. This big fat 3 whole number has a tiny little Juan underneath it. Then we're going to multiply left to right. You get 3/3, and that drops down to a 1, because 3 divided by 3 is 1. Okay, so when I'm multiplying, this 1/3 times 3x just goes to an x. 1/3 times 6, okay, y'all probably don't remember this, but 1/3 times 6, well, put a pretend 1 underneath, multiply left to right, and we get 1 times 6 on top. On the bottom, 3 times 1 is 3. 6 divided by 3 is 2. Okay, so 1/3 times 6 is actually 2. So we have 1/3 times this positive 6 is plus 2, and then there's a minus 2. Well, that cancels out, and we just get x. So the whole point of this problem was to see whether they're inverses. Well, the two equations are inverses if you plug them into each other, and they cancel out to x's. And we plugged them into each other, and we got out x's. So, yes, it's 1-to-1. Huzzah! Okay. And I know those fraction rules seemed like they're not that important, but in about 3 weeks, you're going to be wishing you knew these rules by heart. Okay, so let's keep going with the fraction rules. On number 9, we're going to do the same-ish thing we just did. So first, let's put g into f. So first, let's write down my f thing. Okay, my f thing is this weird fraction. It looks like x plus 1 over 5. Okay, now we're going to put the g in it. Okay, so instead of x plus 1 over 5, we have something plus 1 over 5. And that little something we have is whatever your g of x is. Oh my goodness. Whatever your g of x is. So 5x plus 1. Is that right? Yeah. Okay. So now that I've put our g and our f, we're going to try and cancel to an x. So let's see if this cancels out to an x. On number 8, they canceled because we had a -6 and a +6. Those are opposites. Okay, well, let's see. Do our 1's cancel? Nope. This just makes 5x plus 2 over 5. And the 2 don't cancel. If I split these up, the 5 could cancel. Woohoo! And I could get a plain old x if I canceled these 5s. But that's only if I split it up. If I make like a, what is it, 5x over 5 plus 2 over 5. But even if I split it up and those 5s cancel, woohoo! We still have the rest of that dagdarnit fraction of that 2 over 5. And we have a 2 because our goodies didn't cancel. That 1 plus 1 makes 2. Yeah. So, I don't have just x left over. I have x plus 2 over 5. Boo. So, this is not 1-to-1. Yeah. Oh, my bad. Not inverses. My bad. And over here on number 8, when I said that they're 1-to-1, I meant to say moron. They're inverses. Yeah. Enough of the 1-to-1. Okay, so 1-to-1 means each x has one y, as in there's no repeats. Repeats on the picture, repeats in the point, repeats in the t-chart, repeats in the math. No repeats, no bueno. Okay. So we don't want the repeats. And then for inverses, everything has to cancel to an x. Okay, let's try finding some inverses of equations. Okay, and here are the steps. It says first replace f of x with y. And that's because f of x is the y. Hey, so right off the bat, we take something that's listed as a function, that has the f for function, and we change it to a y just so that we can do our math. Okay, then it says interchange x and y. That means swap, like move the letters. Solve for y means get y alone, and I'm going to say using SADMEP. Like the opposite of PEMDAS. And then the very last step is to replace that y back with that weird f symbol with the -1 in there. That means the fancy word inverse. Okay, so let's see here. First, we're going to find the inverse of the equation, and then we can do the picture. Okay, for the equation, my first step is to change that weird f to the letter y. Okay, so we have y equals 2 plus 1/2 x. So that whole f and the x are gone. It's just a big fat y. Okay. Second step, swap. Okay, we're going to swap the letters. So no more y equals. Now we have x equals. Then the numbers and the symbols all stay the same. And then that x at the back end is now y. So we swap the letters. Okay. The third step is to SADMEP it out. So we're going to get y by itself, but we're going to do that by moving away any subtraction and addition I see, then division and multiplication, then exponents and parentheses. Okay, well, I see a big fat +2 just sitting here. I mean, it's positive. Okay, so it's a pretend plus. Okay, and to get the letter y by itself, I'm going to subtract that 2. Okay, goodbye. Get to subtract 2. And it doesn't actually do anything. It just gets written down. X minus 2 equals 1/2 y. Okay? So I just got rid of addition and subtraction. Yay. Okay, now I'm going to work on the DM. What? That means division, multiplication. Well, I have a 1/2 multiply. Okay? One way to get rid of this 1/2 is to divide it. But ooh, that looks kind of scary, right? Okay, yeah, we're not doing that anymore. Okay, we're not dividing by 1/2 anymore because we're grown up now. Okay, to get rid of that 1/2, we're going to use a new fraction rule. Let's say we have 1/2 y. To get rid of this 1/2, we're going to say, hey, well, this y is multiplying by some kind of divide 2. See how there's a division 2, division bar 2? Yeah, okay. So to get rid of that 1/2, you're going to multiply by 2 on both sides of whatever's happening. Just don't ignore that part. Okay, so whatever is on the bottom of your fraction, if you want it to disappear in an equation, you multiply by what's in the bottom. Okay, so let's see what's going to happen. We have x minus 2 equals 1/2 y. And then we said to get rid of that 2 in the bottom, you can multiply by a big fat 2. Let's see what happens. Multiply by big fat 2. And heck fire, yeah, that 2 and that 1/2 cancel. Kind of like they did like 5 minutes ago with this fraction rule. Yeah. Okay, so that's why we multiply by the 2 on the left. On the right. And then don't forget to do it on the left. And on the left, it's got to distributize. That's the thing I'm worried we'll forget. So 2 multiply x is 2x. 2 multiply -2 is -4 equals y. And then the very last step is to change that y to that funky fresh f to the -1x. Yeah. And this is the equation for the inverse. If I want to graph it, that has a y-intercept of -4 and a slope of 2/1. Or if you don't want to graph it, you can go to y equals, and don't type in the f to the -1 hoopla. Just type in 2x, 2x, and then minus sign 4. Yeah, and the x is up here by the alpha. Alright, there's my graph. Okay, and then if I wanted to go to my, points, I could go to second graph and look at the t-chart, and that's where I can get some of these points. Okay, so let's do this again, but with this bad boy. Okay, and if you're looking at the inverse, it's super awesome because the original... So this original black line, that's the f of x. That's the OG. The original gangsta. No, okay. And then this blue one is the inverse. And what's special about those two is they are a reflection over this diagonal yellow line that I just drew. It's a special type of reflection that comes in handy later in math. Anyway, and so when it reflects over this yellow diagonal line, it's called an inverse. Okay, so this next picture is crazy. But when I draw my inverse, when I draw my two curves, it should reflect over this strange diagonal line. Okay, first let's work on the equation, because that's the big boy. Okay, first we're going to change to just the good old letter Y. Okay, the good old letter Y. Then we're going to swap. And unfortunately, it's going to be awkward. We're going to have x equals 3y for show. And on the bottom, you got to put y plus 1. What? So on the left, that y becomes an x. Yeah. On the right, those x's both become y's. Oh, no. Okay. And then, so we did step 1, we did step 2 swap. Now we have to do SADMAP. What? And the whole point of SADMAP is to get y alone. What? Okay. Well, we're going to do something crazy here. Okay. If we look at this last example, the first thing we did is we got rid of that whole number. We subtracted it off. Well, I can't do that here because this whole number is attached to this big old fraction. Darn. Well, let's get rid of the fraction. Okay, to get rid of this fraction, we're going to do this grown-up trick we did up here, where if you want to get rid of something in the denominator, you multiply it. So if there's something in the bottom of a fraction that you don't want anymore, to get rid of it from underneath, you multiply it. Okay, so here's my fraction. I have a y plus 1 in the bottom. I don't want that anymore. There. Y cannot be in the bottom. It has to be in the top. Like, it's just weird being in the bottom. Okay, so we're going to multiply by y plus 1. And on the right, she goes away. The whole y plus 1 cancels out because the opposite of divide bar, y plus 1, is multiply dot, y plus 1. Those are opposites. They cancel out all the way. The only thing is on the left, I'm afraid we might forget that we have to distribute both the y and the plus 1. Just like up here on the last example, the 2 went to both the x and the 2 to get 2 and 4. Yeah. This y plus 1 has to go to the x, both of them. So y times x is just xy, like the alphabet. 1 times x is just a plusative 1x. Weird. Okay, equals 3y. And then this y plus 1 canceled. Okay. So far, all we've done is multiply something. Now, we're still trying to get at least not just the y's alone, but the y's together. Look at what we have on our paper, and let's find the y's. Hello and hello. They are not together. They need to be on the same side of the equal sign. So what we're going to do is we're going to pick up this xy and put it over here with this 3y. So I'm going to subtract that xy. And when I subtract it, nothing actually happens. On the left, she cankles, fancy. And we get 1x equals, on the right, that does not make anything fancy. It just makes 3y minus xy. Boom. Boom. So you cannot subtract those because they are not like terms. They have different back ends. One of them has an x on it. Okay, so I got my y's together. Yes. Now we're going to do a GCF of a y. What? It's kind of crazy. Okay, so on the left, keep your 1x or your x. On the right, I'm going to say y, open parentheses. And then I'm going to say, okay, if I take away the y from 3y, I just have a 3. If I take this y away from this negative xy, I just have minus x. Okay. And we just did something called GCF. It's like we took out the y and we left in the 3 and the minus x. See how it's still in the parentheses? Okay. Now we're going to divide off the parentheses. And let's see what happens. If I divide off by what's inside those parentheses, it's kind of awkward looking. We don't really care. These are supposed to look disgusting. So we get x over 3 minus x equals, on the right, she cankled. My cankles. And you just get y. Okay, the very last step is to change that funky y to the funky fresh f to the negative 1x. Yeah. Okay, so let's go over that. Again, first, we multiplied off what was in the bottom, because we didn't want a bottom. Second, we subtracted off the y's to put them on the same side of the equals. So we got the y's together. Then we divided off a y, or took off a GCF, or we separated out the y and put the leftovers in the parentheses. Then we divided by what's in those parentheses. Okay, now let's see what the picture would look like. If you're going to go to y equals, I want to teach you a button. Where is it? Yep. Where's that button? Okay, it's alpha, y equals, and then if you have this ND, you can press enter on it. And you'll get, and then we can type the rest of our goodies. X over 3 minus X. So I'll go over that again. You press alpha, y equals, enter. Some of you might have something right here next to alpha. It looks like two little blocks on top of each other. That's also what you can press. You can press alpha and then that X button. And then if you don't have these little blocks, and if you don't have this N over D, then you're out of luck and you're just going to have to type X divided by open parentheses. Back in the day, we would have to put parentheses around the top and the bottom of all fractions, but now most of your calculators are updated. Okay, so either way, you put it in this way, if you have an old school calculator that needs parentheses, or we press alpha, y equals, enter, and type X over 3 minus X, or we type alpha X, and you still get those boxes. And you can do all this in your app also. Okay, so let's go to my T-chart. Oops. And it looks like I have a bunch of equations, but remember, it's because I put in a bunch of equations that mean all the same thing. So let's go to our T-chart. It looks like we have 0, 0. So let's graph that. It looks like 1 and then 0.5. Let's see if there's another one. 2, 2. So to the right, 2. Is this? Yeah, okay. And then what is this? 4, negative 4. Uh, 6, negative 2. I can't really tell what's going on. Okay, let's maybe press graph. Okay, that makes a little bit more sense. Okay, so I got my picture coming up here. And then maybe, okay. And you're thinking, now, what the heck? I thought that woman said that this stuff flops over the yellow line. Well, it does. And this yellow line is y equals x. So watch what happens when I fold this graph. This curve of the inverse is going to land up here on the top left. And this black curve that's already drawn, when it flops, it turns into this blue curve that's super close to it. So if I were to fold this over the yellow line, you can see that this top left curve from the original folds over and lands on this bottom right. So anyway, an inverse is just a reflection over this y equals x diagonal line. Okay. Oh, and also, nope, we'll talk about it. Okay, let's look at number 12. It says the same thing, except for it says for x bigger than or equal to 0. And if you look at the picture, this is x squared plus 3. But just for the part of the t-chart that says 0, 1, 2, 3, just this part of the t-chart. Anything that's lower than 0, like say -1, -2, -3, it's not drawn. So that's what that alligator means. It just means use the right-hand part of the picture, or the part of the picture that just has x values of 0 through 3, or 0 and on. Okay. So first, let's do the inverse. We have to change that funky fresh f to a y. So we'll have y equals x squared plus 3. Then we got to swap. So we have x equals y squared plus 3. Then we got a SADMAP to try and get y alone. Okay, let's see what we can do. We're going to subtract this 3. And when we subtract 3, it doesn't actually do anything. It just gets written down. X minus 3 equals y squared. Okay, so we took care of the SA, subtraction, addition. I don't think I have any division, multiplication, but I do have an exponent. And to get rid of this squared exponent, I'm going to put a house on that wicked witch. And you might remember back from college algebra, anytime you dealt with that pesky quadratic formula, remember that quadratic formula? Negative b plus or minus square root, plus or minus, plus or minus, plus or minus, yeah, plus or minus. Anytime you have a square root from now on, you're going to put a plus or minus on it. Trust me. And this equals plain old y. So on the right-hand side, the squared and the house cankled. Okay, we're going to finish it by putting that funky fresh f to the -1 thing. Okay, and then at the very end, we're going to take this requirement they gave us at the very beginning. Yeah, see how it says x is bigger than or equal to 0? Okay, well, when you inverse that, another way to say inverse is when you swap it. Okay, so when I inverse x bigger than or equal to 0, it's now y bigger than or equal to 0. You see, you just changed the letter. So we started with this x bigger than or equal to 0, okay? And then we're going to end with y. So you swap the letters. So the equation at the very beginning represents this little hook, yeah? And it's just for the x values that are bigger than or equal to 0. But functions that are inverses have x's and y's that are flopped or swapped, or their domains and ranges are swapped. So this x becomes y, okay? And then now, let's use it to write our final answer for the equation. This says y is bigger than or equal to 0. So do you think that means we use the plus or the minus for that square root? Because it says plus or minus, okay? Well, y bigger than or equal to 0 means y is positive. So we're going to use the plusative. And this equation, it's going to have like a little pretend plusative in the front. When you go to type it in, you don't actually type the plusative. Yeah, okay. And when I go to draw this, if I go to y equals, let's remember square root is second x squared. And when I go to draw this, I get x minus 3. Here's my picture. It's a little hook that starts at 1, 2, 3. and it hooks out. Yeah. And I could get the actual points from my T-chart. I'm just being lazy. And I don't think I can graph 28, 5. Yeah, okay. So, let's go over this. I started with a squared, like a parabola, and I ended with a square root. That's because they're inverse operations. They're inverses. They're like opposites. I started with this top hook, and when I reflected it, or folded it over that diagonal, it landed on the second little hook. And the first equation, its domain was x bigger than or equal to 0, but inverse means you use the opposite letter, you swap them, and you change that alligator. My bad, you keep the alligator the same, but you change the letter. So you swap the letter, and then if this would have said y less than or equal to 0, then I would have used a negative on the front of this house. Yeah. Okay, let's keep going. It says the graph of a function is given, graph the inverse function. Okay, this is super lame. Okay, I could either just kind of just wing it, like that, fold and redraw and wing, but I think I'm going to be super pretty. Okay, this point at the top is to the right 1, and then up. This is 1, 4. So that's going to become 4, 1. Because remember, inverses are swapped. The x's and the y's are swapped. So we even do that for the points. 1, 4 becomes 4, 1. Let's draw it. Here's 4, 1. All right, here's another point. It says maybe left 1 up 2. Well, when I flop it, it's 2, negative 1. So 2 to the right. 2 to the right, down 1. This one's a boo-boo. Okay, then keep looking over here at this left. It looks like it's left 1, 2, 3. Left 3, up 1. Swap it. Make 1, negative 3. So when you swap the letters, you take the negative with you. So for this negative 1, 2, the negative stays on the negative 1. Yeah. And the 2 stays positive. Okay, we see that. Let's keep going. This last dot is negative 4, comma negative 2 maybe. So swap it. And then left 2, down 4. Connect your dots. And your dots should look-ish like the original. And then it's folded over that diagonal y equals x line. Yeah.